Welcome, my friends. We are on the last topic of topic 8-4, volume of spheres. And now we get to find volume of composite figures, which just combines different shapes that we've been working with into one. Yeah, it's a good stuff. We'll get to it here in a bit. Number one, example one, page 438. We are talking spheres and volume. So how much stuff will fit into a sphere? Here we go. It's good stuff.
How is the volume of a sphere related to the volume of a cone? Think about this question during the lesson.
Good question.
We're going to find out.
Tay fills the gumball machine
I love gumballs.
using 2 full cone-shaped scoops. Each scoop is 12 inches high, and the circular opening has a radius of 6 inches. The globe of the gumball machine and the opening of the scoop have the same radius and height. How can Tay find a formula to calculate the volume of the gumball machine globe? How can you use the formula for the volume of a cone to determine the formula for the volume of a sphere?
I wonder if they're going to start like pouring these into the sphere to see how many. We know the formula for volume of cone. See how many of these will fit into this. Now these have the same radius as this sphere. So let's see.
Tay used 2 shaped scoops to fill the gumball machine. To find their combined volume, double the formula for the volume of one cone. We'll draw a sphere to represent the globe of the gumball machine. What is the height of a sphere of radius 6 inches? Select your answer.
Height, sphere. What do you think? Want to just take a guess? 12 pi?
Oh, 6 pi.
6 pi.
Oh,
No.
12.
6?
No.
Why would it be 12, everybody? Hey, it's talking about the height all the way across, basically, for this sphere. Well, the radius is 6, so that's where to find the height, multiply that bad boy by 2. There you go.
The height of the sphere is the same as its diameter, and the diameter is 2 times the radius. 2 times 6 inches equals 12 inches.
Yeah.
Use the volume formula for a cone to write the volume formula for a sphere.
This is where it gets fun.
Volume of a sphere equals 2 times the volume of a cone. And we know the formula for the volume of a cone is 1/3 the area of the base times the height. The base is a circle, so the area of the base is pi times r squared. The value of h is the diameter of the sphere, or 2 times r.
You following this?
Yep.
Multiply and simplify, and we have a formula for the volume of a sphere.
That's what we're
Volume
looking
is
for.
equal to 4/3 times pi times r cubed.
That's what we're looking for. Right there. Formula, finding volume of a
Now let's
sphere.
find the volume of the globe of the gumball machine.
Okay.
The radius, r, is 6. Evaluate the exponent. Multiply
Exponent.
and use 3.14 to approximate pi.
Sweet.
The volume of the gumball machine globe is about 904 and 32/100 cubic inches.
Okay. I like it.
Now you know how the volumes of cylinders, cones, and spheres are related. You can use that information to find volumes of spheres.
Just that easy. Just that easy. Let's look at it, try it, my friends. Hey, what is the volume of a ball with a diameter of 6 centimeters? Well, keyword here is it's a ball. That means it's a sphere. Okay? They give us formula for finding volume of a sphere. We want to take 4/3 times pi times the radius to the 3rd power. Okay, we can go back through volume or example 1 if you really want to see, but we're just going to trust this is our formula. So technically, all we need to find volume of a sphere is the radius. We just got to plug it in there because we know 4/3, we know pi, we need to know r. Here we go. The radius, well, the diameter is 6. You guys know this. Radius is half of the diameter, so that means this bad boy is 3. Now, Mr. Knoll forgot his calculator over here, so I got to get it. Evaluate the expression. Well, 4/3 times pi times, so I'm going to put pi right here, and I'm going to multiply all the numerical values together. So we got 4/3, 4/3 times 3 raised to the third power. This comes out to be 36. Now, some of you may not like it like that. Let's put pi in the second box. Make this 36 pi. Approximate value, take 36 times 3.14, and there it is. The volume of that sphere, 113.04 cubic centimeters. Questions on those? Didn't
Nope.
think so. Didn't think so. Questions? I thought there was an additional example, number 1, but we'll deal with more volume of spheres here in a little bit. Okay, let's go to example 2. Sorry. Bingo! Ooh, soccer ball. That's a sphere, everybody. What is the volume of the soccer ball rounded to the nearest whole number? Now, this time, look at this. Remember what we need to find volume of a sphere? The only thing we need to know is the radius. We need to know the radius. They don't give us the radius. They give us the surface area. Remember, they'll never not give you enough information to find stuff. So they gave us the surface area. This is where we got to reflect back and think. Surface area of a sphere was a formula that looked like this. We took 4 times 3.14 times the radius squared. They give us the surface area. So where am I going to put this 1,519.76? In there for S or in there for R? We're going to put it in there for the surface area. So we're going 1,519.76. And we're going to solve that lovely equation.
Booyah.
Step 1, let's simplify these terms over here. 4 times 3.14. Anybody want to guess? I know it. 12.56. Next step, solving this equation. This is a multiplication equation. To solve multiplication equations, we use, say it, division.
Division.
So we're going to divide both sides by 12.56. That leaves us with, well, 1519.76 divided by 12.56. Enter. This comes out to equal 121.
Ooh, that's a good number.
We've worked with squared equations, and I like squared equations that have perfect squares. Okay? We're starting to learn our perfect squares. So, to solve a squared equation, we find the square root, which tells me your radius is equal to 11. 11 it is. Now, remember, this question said find the volume. Volume of a sphere, 4/3 times pi. It says use 3.14 times the radius to the third power. Remember, our radius is 11. Now I'm going to take that 11, substitute it in there for R. 4/3 times 3.14 times 11 to the third power. Now it comes a simple expression. Type it in, press enter. 4/3 times 3.14 times 11 raised to the third power. Holy smokes, it says round to the nearest whole number, so I will. Your volume is approximately 5,572 cubic centimeters. Cubic centimeters. Hey, and you can see that work in your book. I just wanted to do it out here with you because I like going the extra mile.
Yeah.
All right. We haven't tried it. That's disappointing. But maybe we should do another additional example. Should we?
No.
We could. Look, same type of problem. In order to find a volume, remember, we need radius. In order to find the radius, we have to use the surface area of a sphere to find the radius. Ask Mr. Fricky, he'll take you through it. Okay, let's go to example number 3.
Bonus video.
A composite figure is the combination of two or more figures into one object. A corn silo is an example of a composite figure in
I
the
like
shape
corn
of a
silos.
cylinder with a hemisphere of the same
You say
diameter
grain
on top.
silo? Instead?
How many cubic meters of
Yeah.
corn can be stored in the silo?
Lots.
The height of the cylinder is 10 meters, and the diameter is 4 meters.
Mm.
Use 3 and 1400ths for pi. To begin, find the volume of the hemisphere. A hemisphere is half of a sphere.
That's right.
The formula for the volume of a full sphere is 4/3 times pi times the radius r cubed. What is the formula for the volume of a hemisphere?
Do we have one?
Well, what we would have to do, my friends, if we want half of a sphere, find half of that number. So that means we would take and do one of two things. One, you could divide all of this by 2,
Ooh.
or 2, take all of this and multiply it by 1/2. What
Let's
you
do
think of
that. Let's do that.
You want to do that? Okay, we'll see what they do, but again, you find half of it, which means either divide by 2 or multiply by 1/2. Let's see what they say. Oh!
Whoa!
Doggone it.
Whoa!
Doggone it. Okay,
There we go.
we're
Oh,
back.
we're-
We're back. Almost made a mistake there. We're back.
But we didn't.
A hemisphere is half of a sphere, so its volume is 1/2 the volume of a sphere. The diameter of the sphere is 4 meters, so the radius is 2 meters. Simplify the expression to find that the volume of the hemisphere is equal to 16/3 times pi cubic meters.
That's true.
The next step is to find the volume of the cylinder. The formula is V equals pi times the radius r squared times the height h.
Nothing new there. That's
Substitute 2 for
HS3.
r and 10 for h. Simplify the expression to find that the volume of the cylinder is 40 times pi cubic meters.
Okay.
The last step is to add the two volumes. The volume of the silo is equal to the volume of the hemisphere, which is 16/3 times pi plus the volume of the cylinder, which is 40 times pi. Rewrite 40 as 120/3,
Now,
and then add the
we're
fraction.
just going to type those in your calculator.
Using
Press
an
enter.
approximate value of pi, the volume of the silo is about 142 3/10 cubic meters.
And there you go. Let's find the volume of this composite shape, my friends.
Ooh, a cone. It's an ice cream cone.
Looks like an ice cream cone on its side.
Mm.
So it's made up of two things. One thing a cone, other thing a hemisphere. So half of a sphere. Okay, so we got to find the volume of each part, add them together. So let's start with the easier one in my opinion. Let's start with the cone. Okay, volume of a cone.
The cone.
You should know formula, 1/3 times, and it says use 3.14 for pi, so let's do that. Times the radius squared times the height. So plug in what we know from the diagram. We need 1/3 times 3.14. What's the radius? Well, it gives us the radius. That radius is 2. And the height of the cone, the distance from the base to the point, 6. Okay, here we go. 1/3 times 3.14 times 2 squared times 6. That comes out to have a volume of 25 12/100ths. And we are in cubic inches. This is the volume of the cone. Is that all we needed? No, we need the volume of that hemisphere. So we're going to find the volume of the sphere, 4/3 times pi, 3.14 times. I'm okay.
Bless you.
Times radius to the third power. Now, once again, remember, this is a hemisphere, so it's half of one. So we could either multiply all this stuff out and divide by 2, but Mr. Fricky wants to take half of all of this. Half of it all.
Can we
So
just change 4/3 to 2/3 and call it
multiply it
good?
all by 1/2. Now, my thing to you would be, let's take and multiply those two things together as we move to our next step. 1/2 times 4/3 becomes 4/6. 4/6 simplified.
Reduce.
This comes out to be 2/3.
Yeah.
So we got 2/3 times 3.14 times the radius to the third power. Once again, our radius is still 2. Now we have our information. It's a hemisphere, so 2/3 times 3.14. Whoops. Times 2 raised to the third power. This comes out to be 16.75 cubic inches. Composite shape. Find the volume of each one, add them together. So now we need to add those two values together. So 16.75 plus 25.12. Final answer has a volume. Does it say to round anything? So we'll leave it as 41.87 cubic inches. That's the volume of your composite shape there. Okay?
Yep.
That's 8-4. Hopefully that helped a little bit. I know it's somewhat confusing, but the biggest thing, write down the formulas, plug in the information you know, type it in. It's really can be that easy. Okay, see you on the flip side on page 440, I think.
Something like that, yeah.
Concept coming at you.